5H is using the rational root theorem to solve polynomial equations. So the rational root theorem is dividing the constant term by the leading coefficient. This will provide all the possible roots, not all the roots, but all the possible roots. Not actual roots, we have to test them to see if they actually are in the given polynomial. So just a general example here. F of x equals ax to the fourth plus bx to the third plus cx to the squared plus dx plus e. If you take the constant term e and all the factors and you divide those by all of the factors of a, this will list out all of your possible rational roots. So in example 1, we're going to take the constant term of -3 divided by the leading coefficient of 1. All of the factors of -3 are -3, 3, -1, and 1. And all the factors of 1 are +1 and -1. So we have to take each one of these and divide it by each one. So you -3 divided by 1, -3 divided by -1, 3 divided by 1, 3 divided by -1, -1 divided by 1, -1 divided by -1, 1 divided by 1, and the last one, 1 divided by -1. You should already be thinking, well, a lot of these are repeats. -3 divided by 1 is -3. -3 divided by -1 is +3. 3 divided by 1 is +3, so we don't write it again. 3 divided by -1 is -3. -1 divided by 1 is -1. -1 divided by -1 is +1. 1 divided by 1 is +1. 1 divided by -1 is -1. So these four are my 4 possible roots. Now we want to actually find the rational roots of this polynomial. So to do that, we have to test each one of the roots into the polynomial. So I'm going to start with 3. So let's test t of 3, or -3. So we have -3 to the third plus -3 squared minus 3 times -3 minus 3. And if this actually equals 0, then it is a root. So -3 to the third, 27 plus 9, or -27 plus 9 is -18, plus 9 again is -9, minus 3 is not equal to 0, this is equal to -12. So in this case, it equals -12, so -3 is not a root. So let's test 3. 3 to the third plus 3 squared minus 3 times 3 minus 3. 3 to the third is 27 plus 9 is 36 minus 9 is 27 minus 3 is 24. So this equals 24. That is not a root either. It has to equal 0. Let's try -1. -1 to the third plus -1 squared minus 3 times -1 minus 3. So if -1 to the third is -1, plus 1 is 0, plus 3 is 3, minus 3 is 0. So far we have -1 is a root of our polynomial. Let's test the last. So let's test the last possible root, 1. Sorry, that's a 1. 1 to the third plus 1 squared minus 3 times 1 minus 3. So 1 to the third is 1 plus 1 squared is 1. So that's 2 minus 3 is -1 minus 3 is -4. So 1 is not a root. So x equals -1 is the only root. Only rational root. Doesn't mean that there's not other roots. There are. It is to the third power, so there are other roots, but there's only one rational root. There could be irrational roots or imaginary roots also. So here, this is the only rational root. So moving on, we're going to find the roots of 2x to the third minus x squared plus 2x minus 1. So we find the possible roots, the constant term, divided by the leading coefficient, and all the factors. So all the factors of this, of -1, are 1 and -1. And we're going to divide that by all the factors of 2. Pretty easy. -2, 2, -1, 1. Those are all factors of 2. So let's list out the possible rational roots. So 1 divided by -2, -1/2. 1 divided by 2, +1/2. 1 divided by -1. And 1 divided by 1. And then we have -1 divided by -2. -1 divided by 2. -1 divided by -1. And -1 divided by 1. So let's look at what we have here. So the possible roots are -1/2, 1/2, -1, 1. This is 1/2, so we already have that. -1/2, 1, and -1. So these are all of our possible roots. Now we have to test each one of these. So we're testing them. I'll just set it up quick. So I put this into the calculator, put parentheses around the possible roots, enter, and this equals -2.5. So that does not equal 1. So therefore, this is not a possible root. It has to equal 0. So let's test the next one. P of 1/2. So this is just putting in 1/2 in each one. So I'm going to put 1/2 in each, in for each x. We get 0. Awesome. So 1/2 is a possible root. So 1/2 is the possible root. -1/2 is not. Cross it out. 1/2 is. Good. Let's test -1. So testing out -1, and we get -6. So this is not. That is not a root. And lastly, let's test out 1. So I'm testing this out. We get 2. So that is now also not a possible root. The only possible root here is 2, or the only root is 2. So root, or 1/2, sorry, 1/2. We're going to take this root and we're going to make it a factor. Because our goal here is to find the roots. So we're going to find all of the roots. So to make this a factor, this is where you're going to take x equals 1/2, and you're going to subtract 1/2 from both sides. And you get x minus 1/2 equals to 0. And then multiply by 2, the denominator, the whole thing, sorry. 2 times x is 2x. 2 times 1, negative 1/2 is negative 1. And 2 times 0 is 0. So our factor is 2x minus 1. And we're going to divide this factor out of the original polynomial. So 2x minus 1, because the leading coefficient is not 1, we have to use long division. So come back up. We need 2x to the third minus x squared plus 2x minus 1 in the box. Alright, let's use long division here. 2x to the third divided by 2x is x squared. X squared times 2x is 2x to the third. X squared times negative 1 is negative x squared. Now we have to subtract these. Subtract the first terms, they cancel. Subtract second terms, they actually cancel out too. Great. So now what we do, when that happens, bring down the next two terms. You always need to have two terms here. And we just do first leading term, 2x divided by 2x is positive 1. And 1 times 2x is 2x. 1 times negative 1 is negative 1. We subtract these, you end up with 0. So that means that it is a leading, or it is a root. That's good. You should always get 0 here, no remainder. We have to find all the roots. So we have x squared plus 1. That is when we divided out the one root that we had. The factor is 2x minus 1. We now have to solve x squared plus 1. So to do this, you can either use the quadratic formula, but since there's no b here, I think the easiest way is just to subtract 1. X squared equals negative 1. And when you square root now, there's always a positive and a negative anytime you square root. And the square root of negative 1 is I. So we have x equals positive and negative I, and the other root that we found originally was 1/2. So these are all three roots from the polynomial function all the way up top of 2x to the third minus x squared plus 2x minus 1. So this is what the process you're going to have to do. Come to class with questions. I know it's quite a process, but I know you guys are more than capable of it. So we'll just practice.